Hello children. The next topic what we are going to see is about rocket propulsion. How rockets are working out from the launching time to the till it travels in the space, right? In this rocket propulsion, we involve two principles in this. One is what we learned just before, a principle of conservation of momentum, and the second one is Newton's third law. So remember these two laws, very important children. It may be asked in the fill in the blanks, and even for your entrance based competitive examination this will be asked. What are the two laws? First one is conservation of momentum and second one is Newton's third law. Right. How these are all working in the rocket propulsion. That is what we are going to see now. Just a complete theory based concept only children. First one. Now in 9th standard we learned the parts of a rocket. Do you all remember children? If you don't remember, recall that particular pages. Right. That picture. Right. Now in this in combustion chamber and in the fuel chamber, what will happen? The fuels will be filled. That fuels, do you remember? It will be in the form of solid or liquid. And I have used a name for it, propellants. Do you remember? And through combustion chamber, fire will be ignited to the fuels and the fuels will burnt with to a high temperature and will come out through a nozzle. Nozzle means small hole, right? Right? As it comes out with a greater speed, right? So it will produce a high momentum, right? So to balance this momentum, what will happen? So the rocket will try to, how much force is given out? Now the rocket will start to move upwards. This is where Newton's third law is employed here. For every action, action is fuel propelling out, right? That much force, heavy fuels are propelled out. Don't use the word moved out, propelled, gushing out, right? That much the rocket will be lifted up. Action and rocket lifting up is the reaction in the opposite direction. Now here only that Newton's third law is employed, right? Now the rocket is moving, right? Now as it is moving, the fuel will be burning, right? So as the fuel is lost by burning process, ultimately the mass of the rocket will be decreasing as the rocket is moving to the higher altitudes. High altitude means height, right? As it moves up, the fuel will be burnt, the mass will be reduced. Now no external forces acting on the space. What now the next principle of, what is that? Principle of conservation of linear momentum. What is that? Till an external force is acting, only when force is acting, external force is acting, there will be a change in the momentum. When there is no external force, there will not be change in the momentum. Correct children? Now when the rocket is moving, right, to a higher altitude, there is no external force. When no external force is acting, as per that law, linear momentum will not change. So I had explained here. Linear momentum symbol is P. P is equal to M into V. Now I had told, as there is no external force, linear momentum will be constant. There is no change, conserved. These are all the terms to explain it, right? P is equal to M. Now I have told you now, as the fuel is burnt, mass is decreased at an higher altitudes. If mass is decreased, to maintain this to be constant, velocity will increase. Little confused here. I will explain you with a numerical calculation. Now let us take momentum to be 4, right? So it must be maintained constant. The answer what you should get is 4. Now the mass, let us take mass to be 2 kilogram and velocity is 2 meter per second. Right. 2 into 2 will give you 4. Now what I said, at a higher altitude mass will get decreased. Example, decreased quantity, I will take it as 1. Mass is decreased, but answer I should get 4 only. So what will happen to velocity? What should be multiplied with 1 to get 4? It should be 4. So velocity gets automatically increased. So this is where the law of conservation of momentum is used. So in the space, no external force is acting. So linear momentum will be maintained constant. So the fuel will be going up. So as the velocity gets increased, the rocket moves away and away with greater speed. At one particular point, it will reach one maximum velocity called escape velocity, symbolized by V suffix E. Note it down. This is not in your book. V suffix E. This is the velocity attained by a body to escape from the gravitational pull of any planet. So it going out and at a higher altitude by increasing velocity. At one point it will reach one maximum velocity. So it escapes from the influence of the earth. So that particular velocity is called as escape velocity. So can you understand these concepts, children? This is a simple calculative example. Okay. So take down the question. What are the principles involved in rocket propulsion? Right. Explain or give a note on rocket propulsion. Next question. What is or define escape velocity? There is a big derivation for this, children, which you will learn in your higher classes. As of now, know the definition only. Okay, children. So prepare this. Be ready for the next class.